Hi, second year students. Partial fraction, the final journey from 9 to 12, exercise 3.5 and part number 3. The last four questions on partial fraction. How to integrate utilizing partial fraction. First one is good one, but easy. It's good one, a googly type question. It is repeated and irreducible. It is also a linear and repeated. Let's see and find out question number 1. How it goes: dx over x square plus 9. Making life simple, put off dx and integration for the time being. Take only this one, x square minus 9. They can be factored to difference of two squares. Instead of 9, let me write 3 square, and here are the two brackets. From this we can judge it is a linear and different roots. It has linear and different roots. Linear having power 1 and both brackets are different, it gives us root minus 3 and it gives us root positive 3. How to write them in partial fraction? How to split them up algebraically, mathematically? A over x plus 3 plus b over x minus 3 is equal to this one. What we have assumed in that case, we can split this algebraic expression as this: a over first bracket, b over first bracket. This type, this breakup facilitate the integration, integral, and it is simple case of ln and whatever the function is in the denominator. In that case we cannot. We have assumed that 1 over x plus 3 times x minus 3 can be written as this. Taking LCM is x plus 3 times x minus 3, that is a times x minus 3 plus b times x plus 3, 1 over x plus 3 times x minus 3. Moving this from left hand side to right hand side, from division to multiplication, to give you good clue: a times x minus 3 plus b times x plus 3. Here this expression is same, 1 over x plus 3 times x minus 3. Switching this phenomena from left to right, from division to multiplication, x plus 3 times x minus 3 cancel out, we have 1. Multiplying throughout, collecting the like terms and comparing the like parts, it will become a times x minus 3a plus b times x plus 3b is equal to 1. Collecting the like terms, having x first, then constant ax plus bx minus 3a plus 3b is equal to 1. X common, a plus b. Nothing common in that case, it is a constant term, 3a plus 3b, 3a plus 3b. There is no x, one can write to accommodate 0x. Comparing, coefficient of x is equal to coefficient of x. On comparing, we have first a plus b is equal to 0, equation number 1, and second, constant is equal to constant minus 3a plus 3b is equal to 1. Here you have two equations, solve them simultaneously, or from this value of a is minus b, applying substitution technique, put instead of a minus b, that is minus 3 times minus b, that is 3b is equal to 1. Minus plus 3b plus 3b is equal to 1. We have 6b is equal to 1, or this implies that b is equal to 1 upon 6, making life simple. We have value of b, put here, insert here, switch in here, it will become 1 over 6. So a is minus 1 over 6 and b is positive 1 over 6. Introduce here and integrate, it's our answer. Simple enough question, simple enough case of linear and different roots. Let's integrate. Here a times dx over x plus 3 plus b times we have to integrate again, introducing dx and integral symbol. A is our minus 1 over 6. minus 1 over 6 dx over x plus 3, and b's are positive 1 over 6 dx over x minus 3. Simple case. Let me explain again, because explaining over and over again facilitates our understanding. Function is in the denominator having overall power 1. Function is in the denominator having overall power 1 and different derivative present in the numerator. It is the case of ln, whatever is present in the denominator. Its integration is given by this. Function, derivative, function, derivative, function, derivative. But function has power 1, only 1. I have written to emphasize, to give you clarity, to give you some distinction about this case. Function, derivative function having overall power 1, it is case of ln. So does here. Power is 1, differentiation of x is 1, 3 is 0. Same is the case here. It will become minus 1 over 6 ln x plus 3 plus 1 over 6 ln x minus 3 plus c. Okay, we are done almost. Just writing in the answer. First write positive one, second negative. Why? To facilitate our answer, minus 1 over 6 ln x plus 3. Not to look out. Now look, 1 over 6 common. 1 over 6 common. 1 over 6 common. What we are left with? Ln x minus 3 minus ln x plus 3 plus c. Here, utilizing the property of log, that is ln a over b can be written as ln a minus ln b. So writing from left to right, right to left, right to left. We have this situation, we have to convert in that. Right log one time, 1 over 6 ln x minus 3 divided by this one plus c. That's our answer. That's our answer in that case. So integration of 1 over dx over 1 dx over x square plus 9 is 1 over 6 ln x minus 3 over x plus 3, owing to by virtue of partial fraction. Partial fraction. This case I have already emphasized several times, many times on many equations. Function derivative, function having overall power 1. It is the situation of ln. It is the situation of. Otherwise, we have to drag the function in the numerator and add 1 into the power. When function in the denominator is not having power 1. Power 1 is exception. It is case of ln. Moving towards question number 10. We have 1 over x cube plus 2x square plus x dx. Let's see. Let me write here. Dx over x cube plus 2x square plus x. Okay, that is a situation to be taken. For the time being, put off, postpone dx and integration. Taking x common, we are left with x square plus 2x plus 1. We are familiar, its identity, x plus 1 whole square. Here is the whole phenomena, situation in front of you. It is linear as well as repeated. Linear as well as repeated. So a over this one and b, c to be introduced. How? Let's see. Linear and different, as well as this bracket is repeated plus repeated roots. If we find the roots, x is equal to 0 and x is equal to minus 1 are the roots. X is equal to 0 and x is equal to minus 1. But x is equal to minus 1 is the root of two expressions. That is x plus 1 whole square. So it is a repeated root. X is equal to minus 1 is the repeated root. X is equal to 0 is the non-repeated root. How to write them in partial fraction? Let's see and find out. A over x plus b over x plus 1 power 1 plus c over x plus 1 whole square is equal to original expression, that is x times x plus 1 whole square. That is the way to write linear and repeated, linear and repeated, linear and repeated. Here it is x plus 1 whole square. We have tried to b over 1, then 2, then 3. If there would have been x plus 1 whole cube, we would have written b over x plus 1 plus c over x plus 1 whole square plus d over x plus 1 whole cube. Now taking LCM on the left hand side and managing the value of capital A, B, C. LCM is x times x plus 1 whole square. Here it is A times x plus 1 whole square. B, here B times x plus 1, and here it will become only Cx. The right hand side remains same, whole square. Shift this quantity from deviant to multiplication, from left to right, and open this up. A times, open this up, it will become x square plus 2x plus 1. Multiply bx throughout, it will become b x square plus x plus cx is equal to 1 over x times x plus 1 whole square times, shifting this quantity on the right, x times x plus 1 whole square. Cancelled out. Multiply a throughout, it will become ax square 2x plus a plus bx square plus bx plus cx is equal to 1. Ax square plus, let me check. Good. All collecting the like terms, ax square, bx square, then x, then without x. This one too. So I have ax square plus bx square plus 2ax bx plus cx. A constant, only one constant, going to 1 plus a is equal to 1. Taking x square common, we are left with a plus b. Taking x common from here, it will become 2a plus b plus c plus a is equal to. Now we have to manage x square, x and constant. I can write one as 0x square plus 0x plus 1. Now comparing the like terms, a plus b is equal to 0, 2a plus b plus c is equal to 0, and a is equal to 1. So on comparing, a plus b is equal to 0, equation number 1. Equation number 2 is 2a plus b plus c is equal to 0, and c, that is a is equal to 1. We have compared the coefficients. Coefficient of x square is equal to coefficient of x square. No x square means 0. Coefficient of x is equal to x. No x means 0. And constant is equal to constant. Constant is equal to, by mere stroke of luck, we have a direct value a is equal to 1. A is equal to 1. Put here, you will get b. A is 1 plus b is equal to 0. So b is equal to minus 1. Next, we need the value of c. It's simple one. 2, value of a is 1. Value of b is just, we have managed minus 1 plus c is equal to 0. It will become 2 minus 1 plus c is equal to 0. 2 minus 1 plus c, it is positive 1. Shift here, it will become c is equal to minus 1. C is equal to minus 1. So I have a is 1, b and c both are negative 1. B and c are both negative 1. Right here and integrate, right here and integrate. It is case of ln, it is case of ln. It is not case of ln. As par is 2, as par is 2. Let's deal this in detail. A is 1, BC minus 1. A is 1, value of A is 1, B is equal to C is equal to minus 1. B is equal to C is equal to minus 1. Okay. Now integrate. Here, A dx over x plus B dx over x plus 1 plus C dx over x plus 1 whole square. A is 1, dx over x means ln x. Function derivative having overall power 1. Differentiation of x is on function derivative. I have told you several times. Let me write again. F dash x, f of x, having overall power 1. It is the case of ln function. Same situation here. Here, value of b is minus 1. Integrating this one. Differentiation of x is 1 is differentiation of 1 is 0, function derivative overall power 1, and value of b is minus 1. It is negative times ln x plus 1. Here Value of c is minus 1, no doubt, but we cannot integrate here direct. Power is not 1, we drag this power to numerator. We drag this function to numerator. We have ln x minus ln x plus 1. It will become minus x plus 1 raised to minus 2 dx. Differentiation of x is 1. 1 is always present here. Function derivative, function derivative, function derivative, function derivative. Add 1 to the power of function. That is the case here. Integration f of x over all power m. Let me write it. Function f of x raised m, and here is differentiation. Derivative of the function where m is not equal to 1. M is not. If m is equal to minus 1, it would have been the case of ln. It would have been the case of ln. Same. If m is not equal to 1, then we add 1 to the power of function, dividing with the same, and it's our answer. That is the situation here. Function derivative and overall power is not 1. Overall power is not negative 1. Overall power is not negative 1. It is not the case of ln. Simply add 1 into it. Ln x, oh god, ln x minus ln x plus 1 minus 2 plus 1, add 1 to the power, it will become negative 1, dividing with the same, plus c, it will become minus minus plus, turn exponent from negative to positive, and applying tiny property of log here, ln a minus ln b, it can be written as ln x over x plus 1, minus minus plus, here is x plus 1 raised to minus 1, turn exponent to positive, we have ln x over x plus 1 plus 1 over x plus 1 plus c is our answer in that case. What we have done here, just simple property of log, that is ln a minus ln b can be written as ln a over b, ln a over b. Wonderful property to be utilized. All three properties of log. Division can be split into separate log by minus, multiplication to addition with individual logs, and power can become coefficient, and coefficient also become power in case of log. By applying the property of log. Moving towards question, good one. A good googly type question is 11th one. Let's explore this. This mystery as well. They are simple enough. Such type of question is also present with two trigonometric functions, sine and cos, but they are present in our synth board. It is your national book, foundation book. Let's see and find out how to deal this one. It's simple one. Just take a simple effort leading towards much clarity. If we assume that, suppose y is equal to e raised x, differentiate dy over dx is equal to e raised x. Differentiation of e raised x is e raised x. Solve for differential dy, it will become e raised x times dx. Second, and it's number 1. Utilize here, and it is the normal shape of our partial fraction. Our data turns to be, instead of this I can write dy. Instead of this, ex means y plus 1 whole square. Here y minus 2 dy. Look at this. It is elegant question of our normal partial fraction. By simple assumption, we are familiar. Differentiation of ex is ex. Simply suppose e raised x is equal to y, then differentiate and plug in the value, and switching from x to y, it will become simple case of partial fraction, different as well as repeated, linear and different as well as repeated, The two roots are y is equal to and y is equal to minus 1, solved to be later for x. By resolving into partial fraction, I have, it is a repeated case as a over y plus 1 power 1 plus b over y plus 1 whole square plus c over y minus 2. Look, y plus 1 whole square, starting from 1 to 2. If power would have been 4, I have written a raised y plus 1 power 1, b raised y plus 1 square, then cube, then power 4 is equal to original question 1 over y plus 1 whole square times y minus 2. Simply take LCM and solve for capital ABC. LCM is y plus 1 whole square times y minus 2. Here comes a times y plus 1 as well as y minus 2. With B only a lone bracket y minus 2, y minus 2. With C the double bracket y plus 1 whole square is equal to 1 over y plus 1 whole square times y minus 2. Here take LCM, same LCM y plus 1 whole square. Here y plus 1 is present in the denominator, one bracket remains as well as y minus 2. Here y plus 1 whole square, y plus 1 whole square will be cancelled. Here only y minus 2 remains. In that case we have C over y minus 2. Y minus 2 cancel this complete bracket with C. Shifting this quantity from left to right, they are cancelled out. I am saving my soul and making life simple more for myself, for yourself. Just multiply and compare. I have, it will become y square minus 2y plus y minus 2. Multiplying y times y square, y times negative 2, negative 2. 1 times y, 1 times negative 2, it's negative 2. Here it is simple one, b times y minus 2 plus c, open this bracket, y square plus 2y plus 1 is equal to 1. Minus 2y plus y, it will become negative y. So I have ay square minus ay. After minus 2y plus y, I have written minus y here. Minus 2y plus y, I have written negative y here. Minus 2a plus by minus 2b plus cy square plus 2cy plus c is equal to 1. Collecting the like terms, square y square, then y power 1, then without y, collecting the like terms, ay square plus cy square minus ay plus by plus 2cy minus 2a minus 2b plus c is equal to 1. Taking y square common, minus taking only y common, positive y. Keep intact negative sign with a, minus a plus b. I have taken only y common, plus, sorry, there would have been, there is c, 2c, minus, this is constant term, minus 2a minus 2b plus c is equal to what? I have to manage y square, y without y, so I can write freely as 2 0y square over y plus 1. Collecting the like terms, it's equal to 0. Coefficient of y is also equal to 0 and constant a is equal to 1. Constant a is equal to 1. So I have one equation as a plus c is equal to 0. Collecting the powers of y square. Then collecting the powers of y, it will become, second bracket is minus a plus b plus 2c is also equal to 0. The third bracket is minus 2a minus 2b plus c is equal to 1. Coefficient of y square 0, coefficient of y 0 and constant is equal to 1. Constant is equal to 1. Look at this. We have a wonderful mystery to solve here, but it's simple one. If I can manage value of a from here, value of a is minus c. A is equal to minus c. If I substitute in both equations, both in these two equations, in both these equations, I have only BC left, BC. If I manage value of A here minus C, then I left with B and C. To solve B and C in two equations, it's really very easy. Put here, it will become minus C plus B plus 2C is equal to 0. Minus plus C plus B plus 2C is equal to 0. How much? 2C plus C, 3C plus B is equal to 0. This is my fourth equation. Simply put a is equal to minus c here, it will become minus 2 times negative c minus 2b plus c is equal to 1. minus minus plus it will become 2c minus 2b and plus c is equal to 1. How much? 2c plus c? 3c minus 2b is equal to 1. Now look at this. Solve these two equations and they work wonderful for us. 3c plus b is equal to 0 and 3c minus 2b is equal to 1. Subtracting, simply making life simpler, it will become 3b. 3b is equal to minus 1. So b is equal to minus 1 upon 3. b is minus 1 upon 3. Utilizing in this equation are that I am going to arrange all the values. Let me make some space for myself here. Let me write this expression here where I have to put values a over y plus 1 plus b over y plus 1 whole square plus c over y minus 2. Okay, good, we are good to go. Let me read this. So I have some assumptions. A is equal to minus c and I have managed b is equal to minus 1 over 3. Taking any equation, this one or that, putting value of b here, 3c plus b is equal to 0. Putting value of b here, 3c minus 1 over 3 is equal to 0. 3c is equal to 1 over 3. c is equal to 1 over 9. c is 1 over 9. Putting here, I will get value of a. A is equal to minus c. C is minus 1 over 9. So I have value of a, value of b, value of c. Put here and integrate. So I have a over dy over y plus 1 plus b dy over y plus 1 whole square plus c dy over y minus 2 over. It's case of ln. It is also case of ln. ln. In that case, we have to shift power. We have shift function to numerator as power is not 1. We have to shift this function in numerator, then we have to add 1. It is simple case of ln. Value of a is negative 1 over 9. ln y plus 1. B is minus 1 over 3. And I have to write this function in numerator. As power is not 1, in that case, it will become minus 2 dy. C is minus 1 upon 9. Same situation, function derivative of overall power 1. As I have told you several times, it is min ln y minus 2 plus c. It is minus 1 over 9 ln y plus 1. Add 1 into power, it will become y plus 1 raised minus 1 dividing by minus 1. We have done this. 1 over 9 ln y minus 2 plus c. If I write them together, taking 1 upon 9 common, I can merge and re-put the value of y. Here, writing first positive quantity 1 over 9 ln y minus 2. Then this one minus 1 over 9 ln y plus 1. Here, minus plus 1 over 3 y plus 1 raised minus 1. Taking 1 over 9 common, we have left with ln y minus 2 minus ln y plus 1 bracket over. Turning negative part to positive, write function in denominator, it will be y plus 1 plus c. That can be merged by applying the property of log, that is ln a minus ln b can be written as ln a over b. ln a over b. Utilizing this property here, it will become y minus 2 divided by y plus 1, and it is 1 over 3 y plus 1 plus c. Don't forget, we have utilized the supposition y is equal to e raised x. Y is equal to exponential function. Introduce same here. 1 over 9 e raised x minus 2 divided by e raised x plus 1 plus 1 over 3. Y means e raised x plus 1 plus c. It's my final answer. It's my final answer. That's our final answer. A good question. First, we assume that y is equal to x, differentiating and putting values, it will become simple question of linear, different as well as repeated root. We have three roots, and I have done so. Look at the length of this question, and it's wonderful. It's wonderful. Finally, moving towards 12 and final question of this exercise on partial fraction. Let me write the data and erase the rest. I have x over x times dx, x plus 1 whole square, x square plus 1 dx. I have already written that. Okay, let me check x plus 1 whole square, x square plus 1 dx, and the rest. Let me make this space and making my life simpler to have a space to solve a question. Okay, look at this. Linear and repeated, quadratic irreducible in real on or quadratic irreducible in real. It is not reducible in real numbers. It is reducible in complex number. I have already told you. Let me give you a good idea again. X square plus 1, they can be factored into complex number. Instead of 1, I can write minus iota square. Because value of iota square is negative 1, negative, it will be the same. Now we can factorize. So this expression can be factored out in complex number, but not in real numbers. We are generally in our calculus or in your second year book, we are dealing with real valued functions. So we have to omit complex numbers. So that's why it is irreducible in quadratic. Writing the same, resolving into partial fraction a over x plus 1 raised to 1 plus b over x plus 1 whole square. It is quadratic irreducible, don't forget. Its partial fractions are given by cx plus d over x square plus 1. That is the strategy behind linear and repeated roots up to 1, 1, 2. If there would have been 3, I would have written 1, then 2, then 3. And that is the policy behind quadratic irreducible, because their difference of the degree must be 1. Difference of the degree must be 1 in that case. Is equal to the same data that I have written, x over x plus 1 whole square, here x plus 1, and it is something dx. Taking LCM, that is x plus 1 whole square times x square plus 1, here 1 time, let me write a in a proper fashion, a times x plus 1 cancelled out, a single x plus 1 times x square plus 1, and in that case x plus 1 whole square can be cancelled out. We have left with b times x square plus 1, and in that case cx plus d, x square plus 1 have been cancelled out. We are left with x plus 1 whole square is equal to x over x plus 1 whole square times x square plus 1. They are cancelled out, knowing the fact that we shift this one from denominator to numerator, from left right, they are cancelled out. How to negotiate them? It works wonderful for us. Let's see and find out. A times x plus 1 times x square plus 1, b times x square plus 1 plus cx plus d times x plus 1 whole square is equal to x. Let me have a look at this, knowing the fact that when you have proximity with the board, and it's your mind works lesser, otherwise it works wonder. A times x plus 1 x square plus 1 beta, good. Okay, now I multiply, leaving a little space here because of owing to one step that I have to solve. Why? Let's see and find out. Just multiply them. A times, it will become x cube plus x, then 1, it will become x square, 1 times 1, 1. X times x square, x cube, x times 1, x. 1 times x square, 1 times 1, 1. Here, it's simple one. Bx square plus b. Here, take care. First open this bracket, x plus 1 whole square. I have cx plus d times x square plus 2x plus 1 is equal to x. We have done so. Write in a good fashion, ax cube plus ax plus ax square plus a. X cube, ax, good. Bx square plus b. Oh, take care here. It will become cx cube 2cx square only cx. Dx square 2 dx plus d is equal to x. Let me check. Cx cube 2cx square cx only. Dx square 2 dx plus d is equal to x. Collecting the like terms, two terms having cube, then square terms. Oh god, then 1, then having power 1. Cool question to solve. Ax cube plus cx cube. Good. Then square terms, ax square plus bx square plus 2c x square plus dx square. Cool. Then power 1, ax cx 2 dx. Good. Then constant terms, I have a plus b plus a plus b and plus d. No c. Plus d is equal to, I have to manage x cube, x square and x. Let me write here 0x cube, 0x square, x is there, no constant means 0. come taking common x cube, then comparing x cube common, I have a plus c. Taking x square common, we are left with a plus b plus 2c, 2c plus d as well. Taking x common, a plus c plus 2d we are left with, and the constants are a plus b plus d is equal to 0x cube plus 0x square plus x plus 0. Bingo! So we have a plus c is equal to 0. Coefficient of cube is equal to coefficient of cube. Coefficient of x square is equal to x square. Coefficient of x square are a plus b plus 2c plus d is equal to 0. That's equation number 2. Equation number 3. What's equation number 3? I have a plus c plus 2d is equal to 1, because here coefficient of x is 1. Comparing a plus c plus 2d is equal to 1. What about the constants? A plus b plus d is equal to 0. Our life is not simple. Our life is miserable enough in that case. We have to manage a value also. From where here? Take the assistance or help of the roots. What is one root? From this complex root is possible. X is equal to plus minus iota to be left out. This one, x is equal to 1. This expression gives us the root x is equal to minus 1. This expression gives us the root x is equal to minus 1, and it is going to work 1 now. X plus 1 is equal to 0. X is equal to minus 1. Put here and manage at least one value. If I put minus 1 here, it will become minus 1 and plus 1, 0. They are all cancelled out. If I put minus 1 here, minus 1 and plus 1, they are also cancelled out here. This one remains. Put value of x is equal to minus 1. I have left with minus 1 square plus 1, and here it is minus 1. So b1 plus 1 is equal to minus 1. From this, b is going to be minus 1 over 2. B is going to be minus 1 over 2. This little value is going to help us a lot. This little value is going to help us a lot. Let's see and find out how. RB is minus 1 upon 2. RB is minus 1 upon 2. Still we have to do a lot of calculation. Put value of B is minus 1 upon 2 here and here. This equation will become a plus d is equal to minus b, or a plus d minus value of b is minus 1 over 2. Minus 1 over 2. It will become a plus d or positive 1 over 2. Positive 1 over 2. Okay. if I put value of b here, it will become something like a b means minus 1 over 2 plus 2c plus d is equal to 0. Oh God, shift 1 upon 2 here, it will become a plus 2c plus d is equal to 1 upon 2. So I have this equation in ACD, this equation is AD, and from this I can manage the value of A is equal to C or C is equal to minus C. Let me erase and make a space, then think what we have to do. Okay, God helps us. Our first equation is, let me write A plus C plus 2D is equal to 1. And from this, and second equation is going to be this one, A plus 2C plus D, this one. One bracket is A plus C, that second one is this, A plus 2C plus D is equal to 1 upon 2. Good. A plus D is equal to positive 1 upon 2, and I have A plus C is equal to 0. A plus C is equal to 0. What I am going to have? A good one. We can work. Look at this. A plus D is equal to 1 over 2. A plus D is equal to 1 over 2. If I utilize A plus D is equal to 1 upon 2, then I am going to have the value of C. I am going to value of C. If C, then they can crumble like a deck of cards. A plus D plus 2C is equal to 1 over 2. A plus D is equal to 1 upon 2. Introduce here. 1 upon 2 plus 2C is equal to 1 upon 2. 2C is going to be 1 upon 2 minus 1 upon 2 cancelled out. 2C is equal to 0. So value of C is 0. If C is 0, put here A plus 0. So value of A is also 0. I have A 0, C 0, and mine B is minus 1 over 2, and mine B is minus 1 over 2. What I am left with? D. I have to find D. From here, I can easily manage value of D. From here, I can easily find value of D. A and C both 0. I can manage D even here. From here, A plus D is equal to 1 upon 2. Value of A is 0. So D is 1 upon 2. One can verify taking this equation. A plus C plus 2D is equal to 1. A is 0, C is 0, 2D. Then D is going to be 1 upon 2. I am going to work wonder. B is negative 1 upon 2 and D is positive 1 upon 2. A and C are 0 and we are done. Oh, I have erased the question as well. Pass me the book. What is the question? We have to integrate in that case. I have erased the question as well. Let me manage the question. I think it's final question. Question number 12. Question number 12, 3.5. Yes. Let me write the question. X dx over x plus 1 whole square. X square. That is A over x plus 1 plus B over x plus 1 whole square. Linear and repeated technique. And Cx plus D over x square plus 1. A is 0. C is 0. B is minus 1 upon 2 and D is positive 1 upon 2. Making life simple, putting these values and integrating. A is 0, no more. This C is 0, it is no more. We have B, B means minus 1 over 2, dx over x plus 1 whole square plus 0 times x, value of C is 0, value of D is positive 1 over 2, overall x square plus 1, it's no more. Here, function is not equal to 1, shift the function into the numerator, turning the exponent from positive to negative, dx, integrating it fully, adding 1 into the power, function derivative situation, differentiation of 1, that's always present here, adding 1, dividing with the same, plus, it is the simple case of 1 over 2, writing outside constant, here d, it is r 1 plus x square. We are familiar, differentiation of tan inverse x is, 1 over 1 plus x square, 1 over 1 plus x square. So its integration is given by 1 over 2 tan inverse x plus c minus minus plus, turning the exponent to positive, drag it down in the denominator, 1 over 2x plus 1, that is 1 over 2 tan inverse of x plus c. I have already given you the clue of this can also be done by magic substitution. By magic substitution, let me give you a good idea again. Let me repeat this for you. If that is the situation, dx over 1 plus x square, compare, this is the general term, general form, where we have to compare, we have to take the supposition x is equal to 8 tan theta. Converting this one into this, instead of 1 write 1 square, here x is x and value of a is 1. Suppose x is equal to 8 tan theta, a means 1 tan theta. Differentiating with respect to theta, dx over d theta, differentiation of tan is sec square. Solving for differential dx, that is sec square theta d theta. Number 2, number 1, utilizing here, we have dx means sec square theta d theta, overall 1 square, x means tan square theta. We are familiar, 1 plus tan square is equal to sec square, 1 plus tan square is equal to sec square. Cancelled out, d theta means theta plus c. Manage the value of theta from here. To remove tan, introduce tan inverse or arc and both here. So we have theta is equal to tan inverse of x over 1 plus c, or tan inverse x plus c, it's our answer. So the final answer of this one is 1 over 2 times x plus 1 plus 1 over 2 tan inverse of x plus c. Partial fraction, bingo, bye bye, that's no more. Inshallah, see you soon in exercise 3.6, the application of definite and indefinite integrals. And see you soon. It's all by itself. Next.